not. I feel like we usually have different lighting in here. I don't know. Okay, cool. I think we are all good to go here. Uh, 14. Cool. All right. So, I guess sad news, not for you guys. I'm abandoning Slack. It just is taking too long for me to get everyone kind of on board. There's Slack issues, everything. So I'm migrating everything to Moodle. If you made it onto Slack, congratulations, you did it. If you didn't, oh well, no harm, no foul. So everything will be on Moodle from now on. Everything will be on Moodle from now on. So I've migrated everything over there, okay? And so everything's on Moodle. You don't have to worry about Slack anymore. I know, what a bummer. I'll try it again next term, but that's not you guys, so who cares? Which means I had to figure out a way to host my videos. I ran out of Zoom storage. So now I have a YouTube channel. I know, right? So feeling pretty cool. Yeah, so you can check out my YouTube channel for all the lectures. And I posted the link on Moodle as well, right? So all lecture videos will be posted on YouTube. So if there's things in your notes that you're kind of like, oh, what happened here, right? Or maybe you missed a day or whatever, then you can just watch the videos. They'll be slow going, right? But it's okay. I think you can speed through. I'll post, I haven't figured out how to claim my own Zoom room. But once I do that, then I can just have that always open. And that's where our online, meetings will be held. So if you're joining from outside of class, right, during the class time, then that's where we'll be always. So it's not an individual meeting every time. But like I said, I know I can do it. I just haven't done it yet. Okay. So that's how it will be. Okay. Any questions about that? Cool. All right. So, you can search, if you're just on YouTube, you can search for me. And even though I'm the only direct hit, I'm the third in the list. So I've got some work to do, I guess. Not that popular yet, but I will be in no time. Okay. And once you're on there, it'll show you, I think, the most recent files. And I do have all my lectures on there. So the other section of business math and my Stat 121. So you'll just have to, figure out which ones you want to watch, right? So they're all in the same place. I haven't divvied them up, so I'll leave that up to you. Okay? But they are all there. It only shows the first few. So I had a couple of people this morning say I hadn't posted the video from last day, but I had. So yes, a win for me. All right. So we'll do a little bit of review. We're not going to really come back to it today, so I'm not going to do any examples. The one example we did, right, was pretty long. So hopefully you went into your textbook and you tried to find some examples in there. No? All right. Don't worry, I'll force some examples on you later. Or some practice problems, I should say. But just as a quick review, last day we talked about 2 ways that we can maximize a profit function, right? Seems like a reasonable goal if you're in business, right? You want to maximize a profit function, right? And so we learned about 2 different ways that we can do that depending on 2 different problems, right? And so we used linear programming to maximize a profit function. Given a set of constraints, right? So I gave you the profit function and then I said, x has to be greater than 0, y has to be greater than 0, 2x plus 3y has to be less than 14, for example, right? And things like that, those constraints. Okay. Given a set of constraints, okay, and the steps we followed, right, were the first step, we have to graph all these constraints. That took a little bit of work, right? Because the day before we had talked about how do we graph straight lines, right? And so we have to find 2 points on each line, connect the dots, right? And so we have to graph the constraints to find that feasible set, right? The area that satisfies all the constraints. Okay. So we graph the constraints to find the feasible set, which I called it that loosely, right? The area that satisfies all the constraints. The area that satisfies all the constraints okay. And then we said, just as a fact, okay, the profit function will be maximized at one of the points of intersection, right? So not in the middle, but at one of the extremes, right? So what we do is we identify all the points of intersection, find the ordered pairs, right? The XY combinations at each of those, make a list, evaluate the profit function at each of those points, the highest profit. You've done it. You've maximized the profit function. All right. So step 2, right, was find all points of intersection. All points of intersection. Step 3, evaluate the profit function. So that's the first time that the profit function actually comes into play, right? We just kind of leave it to the side until we have all the points of intersection. So evaluate the profit function at all points of intersection. All points of intersection. And then, of course, the point, right, the XY combination that maximizes the profit function, that's where your profit function is maximized, right? So the profit, or the point, sorry, the point that maximizes the profit function is the optimal solution. Cool. So that was one way, right, where I give you the profit function and then I give you a list of constraints, right? So that's kind of the basic way. And then there are certain cases where I give you a function and I ask you to maximize it, right? So there are no constraints here, but we use calculus, sort of, fake calculus, right? Where we take the derivative of the function, set it equal to 0, because we said the derivative, right, is the slope of the tangent line at each point on the curve. Tangent line only touches one point on the curve and it's straight, right? And if the slope is 0, then you're either at a maximum or a minimum, right? The top of a curve or the bottom of a curve. We only care about the top, right? And so we set the derivative equal to 0 and find the point where the profit is maximized, right? And then evaluate the profit at that point. Okay. I know. So the second way we talked about was maximizing a profit function, really any function, with calculus. Fake calculus. No, it's real, but we didn't talk about all the theory and stuff, right? We just said that the derivative of f of x, remember, is denoted by f prime of x. Okay. And f prime at a, right? Evaluate the derivative at a, okay, is the slope of the tangent line, at x equal to a. And I'll just kind of reiterate what we said last day, right? So since the slope of the tangent line, at the maximum point, I should say, since the slope at, things got jumpy. At the maximum point, of f of x will be 0. Okay. We set the derivative of f equal to 0. Okay. And solve for the value of x that makes that true. And solve for the value of x that makes f prime of x equal to 0 true. Okay. This value of x maximizes your profit function. Maximizes your profit function. So as an example, if I ask you to maximize f of x is 4x squared plus 3x plus 2, our first step, right, is to take the derivative of this. And we said, okay, we're not going to talk about the theory so much. We just give our equation a bump, right, from the right. And so the power of the x's fall down and multiply each of the coefficients, right? And then the powers decrease by 1. Right? So if your highest power in your original function is x squared. In the derivative, your highest power is just going to be x, right? So all the powers decrease by 1. So you end up with a simpler function. So step 1 is to find f prime of x. Right? F prime of x in this case is going to be 4 times 2, right? Bringing that power of 2 down in front, x to the power of, I'm going to go a little quick here, right? 2 minus 1 is just 1. Plus 3. The x goes away, right? X to the power of 1. 1 in front, nothing happens. 1 minus 1 is 0. X to the power of 0 is just 1. So technically you have 3 times 1. And then the derivative of a constant is just 0. Okay. Or if you wanted to just skip to 8x plus 3, that's fine by me. Okay. Cool. So that's our first step, right? So this gives us a function for finding the slope at all points of x. Right? And so now step 2, set f prime of x equal to 0 and solve for x. Questions back there, or hello? Questions or no? No questions? Okay. So f prime of x equal to 0. So then we have f prime of x. I'm forcing it to be 0, but it's also 8x plus 3. Solving for x, we can move the 3 over to the left-hand side, so we get negative 3 is 8x. Solving for x, we have to divide both sides by 8, right? And so we get x is negative 3 divided by 8. I'll just leave it at that. Right. We get nasty examples when I make them up on the fly here. Oh well. Can't win them all, right? So at x equal to negative 3 over 8, we've maximized this function. Okay. And so I guess too late now, should have been negative. Anyways, the other, it doesn't matter. My original function should have been negative to start, but it doesn't matter. They will be for you guys when you have to work with them. So they'll work out nicer than x is negative 3 over 8, is what I'm saying. But no matter. Okay. So step 3, evaluate f of x at the x from step 2, right? Because f of x is maximized at negative 3 over 8, right? But we want to know what is the maximized value of the function. So then we remember that f of x was 4x squared plus 3x plus 2. So f at negative 3 over 8 is 4 times negative 3 over 8 squared plus 3 times negative 3 over 8 plus 2. I'm not going to bother evaluating it because the ones you would see would be way prettier. Simplify way easier. Okay. That's my bad, picking a bad function. But it looked so reasonable, right? Oh well, can't win them all. Okay. So that's how we do it with derivatives. Okay. All right. Any questions before we start the new stuff for today?
Take a photo of this one for you.
Yeah, for this one. If it's nice, then yeah, finish it. But this one got ugly, so don't. Okay, then that is the end of the review. So now we're going to change gears into something a little bit more reasonable again. We kind of drift back and forth. We'll deal with derivatives just briefly again, even though I think I promised you that we wouldn't. We do for just like half a day. And then we're back out. So section 3.2 is on merchandising. Oh, back to, well, non-derivatives, I guess. So we have to establish a bunch of terminology that we'll use and definitions that we need to be able to apply. Okay. So the first thing that we're going to talk about is the list price. So the list price, when I say list price, I mean the price at which the product is sold in the end, or suggested to be sold at, right? So the end cost to us as consumers, right? That's going to be the list price. So price at which a product is suggested to be sold at. I guess it's suggested by the manufacturer. Manufacturer. Okay. And so the list price denoted by just the capital L. Okay. So far, so good, right? Okay, list price, we got it. Okay. So, yeah. Oh, denoted by, so just in shorthand, we'll use a capital L to say this is the list price. So if I say the list L is $14.50, right? You're supposed to know that. I mean, the list price is $14.50. Cool. Cool, cool. So the next thing we have to talk about is the trade discount rate. So we kind of know how a distribution chain works, right? So someone manufactures a product and then they sell it to someone else, right? They mark it up a little bit, sell it to someone else, and then they sell it to someone else, mark it up a little bit, right? Or if we're working backwards, right, from us as the consumers to whoever we bought it from, right? They have a little bit of a trade discount from compared to us, right? And whoever they bought it from, they have a little bit of a trade discount, right? And so on and so forth. So it becomes this kind of a fishy motion, right? So depending on how many layers there are in this distribution chain, right? Each layer has some sort of trade discount. Otherwise, why would they be a layer in this chain, right? If they're not getting a cut, right? And so a trade discount rate is a discount applied at each step of the distribution chain, sorry. Discount applied at each step of the distribution chain. Okay. So each of these discounts is going to be denoted by a lowercase d, right? Or in the case where we have multiple discounts, right, D subscript 1, D subscript 2, D subscript 3. It's hard to say. Blah, blah, blah. Okay. But they're going to be denoted by D, or D subscript 1, D subscript 2, D3, etc. in the case of multiple discounts. In the case of multiple discounts. Okay. So then we're going to talk about the net price. The net price is the price to acquire the product, right, at each level of the distribution chain, right? So each little step in the distribution chain has their own net price. Right? So it's the price to acquire the product at each level of the distribution chain. And it's going to be denoted by capital N. Right? Okay. So now that we have these definitions, we can say, okay, well then the net price, right, at any level of the distribution chain, right, is going to be the same as the list price minus the trade discount, right? Whatever trade discount they're at, right, that gets subtracted from whatever we're paying for it, right? Minus the trade discount. The trade discount, right, is going to be some proportion of the list price, right? So if I say, oh, I got this at 30% off the list price, right, that 30% is my trade discount. And so we can say that N, just using our notation, is L minus the list price times the trade discount, right? To figure out how much is being subtracted from the list price. Or if we want to factor out the common L, which we do, I'm telling you, okay, we can rewrite N is L times 1 minus the discount. So the discount, right, would be reported as a percentage. Remember, when we're working in math, we want to convert our percentages to just proportions, right, decimals. So if I say, oh, the trade discount is 30%, right, then we would say, okay, then the net price is the list price times 1 minus 0.3. Right? Okay. Or if you have multiple discounts, then it's going to look like this. So, or with multiple discounts, N is the list price times 1 minus D1 times 1 minus D2 times 1 minus D3, etc., etc. And that's going to be on your formula sheet. And I'll bring your formula sheets, I guess, next day, because then we'll have seen some of the stuff on there and it won't be all mumbo jumbo. Okay. Should have brought them today, I guess. But that's going to be on your formula sheet. So let's have a look at an example that I snapped a picture of. It sure is. Oops. 66. It's example 78. Oh. Tricky with the curvature of the book here. Let's see what I can do. Whoa! Rawlings is offering a trade discount of 38% off bats to sporting goods stores. I know it's small on there, but I can't make it any bigger. Okay. So what will be the cost to a sporting goods store to purchase a bat listed at $135? Right, so the list price is $135. Right. So we're told some things. The list price is $135. Okay. And then Rawlings, I guess, is the manufacturer of the bats. Okay. And so they're offering a discount of 38%. Or we should be working with 0.38, right? That's our discount, our lowercase d. So what will be the cost to a sporting goods store, right? This is essentially asking, what's the net price? And we know on our formula sheet, and we just derived it, the net price is the list price times 1 minus the trade discount. The list price we said was $135 times 1 minus 0.38. Fed mass brackets first, so we're going to simplify the brackets. So we get 135 times 0.62, right? We don't want to muck it up. So I have 83.70 cents. So that's the net price that they bought it for. Right, so the store buys it for 83.70 and then essentially marks it up to 135. Yeah. 1 minus 0.38 in the brackets there. All right, because we have to simplify the brackets before we can keep going. If you wanted to jump from here to here, that's fine. It just might be nice to show some work just in case. I'll delete that arrow. Get confusing. Any questions about that one? Okay. Let's steal another example. Example 80. We've got a different curve this time. Try to make it as big as I can. Can't really see it on there, but TI calculators are sold to the retailer at a net price of $32.15 per calculator, while the retailer sells the calculator for the list price of $43.95. What was the trade discount given to the retailer? So what you'll find with these problems is the hardest part is probably figuring out what's what here. Right? But once we do, right, so we can say, okay, well, the net price we're told is $32.15. Right? And the list price is $43.95. And we want to find D. Right? What was the trade discount given to the retailer? So from the formula that we have, right, N is L times 1 minus D. There's only one discount that we know of. So then we can say, okay, well, N is $32.15 and L has to be $43.95 times 1 minus D, right? So this one's a little bit trickier to solve for, but as long as we keep our heads on straight, it's going to be fine, right? So we have to divide both sides by $43.95. So we get $32.15 over $43.95 is 1 minus D. I'm dropping the brackets because we don't need them anymore, right? We're not multiplying 1 minus D by anything anymore. Okay. Grab my calculator here. Oops. 32.15 divided by 43.95 is 0.73151308.3. Now remember, you don't have to write out all the decimal points as long as you keep them all in your calculator and work with all the decimals, right? I write them out so that if you're going back and checking your calculator work, that you can make sure that they're the same. Right? So as long as you keep 2 or 3 or maybe 4 decimal places if you want in your work, right? But keep all your decimal places in your calculator, you'll be fine. Is 1 minus D. Couple of ways we can do this, right? We can, I do a quick switcheroo. I add D to both sides and I subtract 0.73 from both sides. Do a little, right? Which is the same as subtracting 1 from the left-hand side and negative D, which I have to convert to a positive, right? And so I get, I'll do it phase-wise for now, 0.73151308.3 plus D is 1, so D is 1 minus 0.73151308.3. But in the future, I'll probably just axe that middle step, right? I probably won't do this one. I better erase that in case someone reads back and that won't make sense. It's still right? I just won't show it. Yeah. So we'll get more comfortable just kind of switching things around, make it more convenient, right? So then the D, right, is 1 minus the one that we have on our calculator for now, right? I'm going to use the trick where I just make the 0.73, right? Because I want to keep all my decimal places in here. I make it negative, and then I add 1. It's the same thing, right? So I use that trick to keep all my decimal places in my calculator to get 0.268486917. 6917. I just kissed my calculator. 6917. Is that what you're getting? No? Yeah. Cool. So, or a trade discount of roughly 26.8%. Right? So the trade discount is approximately 26.8%. We still like to talk in percentages.
Do you want us to show decimal longer percentages?
It depends. On the test, I'll make sure that if it's important, I'll tell you. Give your answer to 2 decimal places, for example, or give your answer to 1 decimal place or whatever, right? Otherwise here, I just decided to call it quits at 26.8. 26.85 would be good. I wouldn't go as far as 27, right? I wouldn't round it to a whole percentage, just because 27 and 26.8 is a little bit different, right? So it's kind of a judgment call. But like I said, on the test, I'll make sure to tell you if it's important, how many to use. Is that kind of, I know that's vague, but you'll be okay. As long as you follow my instructions when I do tell you how many decimal places to use, you'll be fine. Okay.
Now, could we, instead of doing all that, just do list price minus net price over list price? Get the exact answer. Would that be marked wrong?
No, as long as you show your work. Yeah, then it's fine. I'm just using the formulas on the formula sheet. Yeah, that's good. Oh, there. Yeah, exactly. Yep. Cool. Let's see an example with more than one trade discount. So let's go to 81. So Rona can purchase bags of soil from their distributor for a list price of $3.25, less discounts of 25% and 10%. What's the net price that Rona pays for a bag of dirt? So we're told that the list price is $3.25. And we're told that the first discount is 25% or 0.25. And the second discount, right? So now we have multiple discounts, is 10% or 0.1. And we want to find the net price. Cool. So now we have 2 discounts. So we can write out our formula with 2 discounts. So just in general, we have N is the list price times 1 minus D1 times 1 minus D2. So we're told that the list price is $3.25 times 1 minus 0.25 times 1 minus 0.1. Dealing with our brackets, right? Simplifying our brackets, we get 325 times 0.75 times 0.9. Now I'm just multiplying everything, so now the order doesn't matter, so I can just multiply through. And I get, I'll do it on here, 3.25 times 0.75 times 0.9, 2.19375. Now we're talking money, right? So we need two decimal places, right? The net price and the list price, those are prices. So we do two decimal places. So N, the net price, is $2.19. Once we round it. No, because the 9's followed by 3. So if it's followed by something less than 5, but not equal to 5, right, then we have to round down. 5 or greater, we round up. Okay, let's do another example. Oh, what the? Example 82. Basically the same until it's not. Okay. So discounts of 25% and 45% were given on the purchase of wine. So the list price for the wine was $32.50 per bottle. A, what was the net price to the retailer? So just the exact same thing that we just did. Right? And B, what single discount would be equivalent to the 25% and 45% discounts? Right? So it's B that I'm after here. Okay? But we'll do A just to ease into it. Right? So we have a first discount of 25%, or if you want to start just writing the decimals, that's fine too. Second discount is 45%, or 0.45. And the list price is $32.50. So part A, what was the net price to the retailer? So N is the list price times 1 minus D1 times 1 minus D2. List price is $32.50. We know that, right? This is the same setup as the one we just did. So I'll go a little bit faster. 1 minus 0.25, oops, times 1 minus 0.45. Maybe not too fast. $32.50 times 0.75 times 0.55. $32.50 times 0.75 times 0.55. 13.40625. So N, right, rounding, we get 1341. So now we know the net price, right? We know the net price, we know the list price, and we know that there were two different discounts, right? But now in part B, what single discount would be equivalent to the 25 and 45% discounts? And so now there's a couple of ways that we can solve this, but I'm going to use the formulas that we've been working with all along, right? And so we're saying, okay, we know that the net price is the list price times 1 minus a single discount, right? And that's what we want. We want to find that single discount that takes a list price of $32.50 to a net price of $13.41. And so we use the net price of $13.41 and the list price of $32.50. And we want to solve for D. That single discount that does the same thing as those two discounts. Okay. So we did an example like this, right? We have to divide both sides by $32.50. So we get $13.41 divided by $32.50 is 1 minus D. So $13.41 divided by $32.50 is 0.41261538.5 is 1 minus a D. Here's where I'll do that little switcheroo and say, well, then D must be 1 minus 0.41261538.5. So we get a discount of 0.58738461.5. Okay. Therefore, a single discount, and that's important, right? Because if I'm just saying, okay, you're going to take 25% off and then 45% off, that's not the same as just adding those two percentages and taking it off, right? 25 and then 45 is the same as 58.74% off, right? So order matters. So a single discount of 58, I'll say 74%, is equivalent to discounts of, what order did we have? 45 and then, or 25 and then 45 of 25% and 45%. Right. So that's important to keep in mind, right? That it's going to matter, right? If you have a series of discounts, that's not going to be the same as just taking them all at once, right? And then, so this is how we would find the equivalent discount. Any questions about that one? Yeah.
I got a slightly different answer.
Uh-oh.
When I got
What'd
to
you
the
get?
second step, right? I just went to 13.15 is equal to 32.50, right? Times 1 minus D. Then I factored in the 32 point.
Could be because it should be 13.41, right? So maybe that's it. There you go. Maybe. We can have a look, but sounds like it's just the 13 point, yeah. But yeah, there are lots of ways to do it, right? I'm just going to stick with the formulas that we have on the formula sheet, even though they do take, like, there are quicker ways to find this out, right? But like I said, I want to work from just the formulas that we have, so we're not just branching out and having things willy-nilly, right? Just kind of keep it simplified here. Right? In doing that, we do a little bit more work, but we have less formulas to keep track of. Right? So, but like I said, there are other ways that we can find this for sure. Cool. All right, let's talk markups then. Speaking of. So I think we're all kind of familiar with markups. We have a selling price is the unit price plus the markup. Same idea, just kind of looking at it from a different perspective. So my selling price is the actual price that I paid plus the markup. Right? Where the markup is made up of two things. It's going to be made up of the overhead expenses, right? So your expenses and your profit, right? Because your markup has to cover those two things. Profit, that's important, right? But also you have to be able to cover all your expenses. Right? So the markup is the overhead expenses, expenses plus the profit. Yeah. Exactly. Yeah. No. Yeah, so in an example, I'll tell you what the profit has to be, right? Or I'll ask you what is the profit, right? So there's no formula for it. It's just kind of decided by whoever decides those things. Okay. So here, right, just to give our notation, so we let S denote the selling price, C denote the per unit cost, right, the unit price, M is going to denote the markup, here's the one that throws me for a loop. We're going to use E for the overhead expenses, just because O looks like a 0, so we shouldn't really use O, right? So we had to pick another letter. Let's go with E, expenses, right? You can just think of them as expenses. So E is going to be the overhead or operating expenses per unit. Almost forgot. And then back to normal, P is going to denote profit. So now, right, we can look at these first two formulas that we laid out. They should all seem pretty reasonable, right? The selling price is going to be the unit price that I paid to buy this thing plus whatever markup I need, right? So S must be the cost, C plus M, right? And where M, right, is made up of two things, E and P, the overhead expenses and the profit. Right? So we have these basic formulas. S is the cost plus the markup. Right? Where the markup is the expenses plus the profit. Right? I can make one big formula if I take the M and substitute it into the first equation, right? So we can write S is the cost plus the markup. So it must be the cost plus the expenses plus the profit. Brackets aren't doing anything, right? Because they're not multiplying anything. So we can just write it out as C plus E plus P if we want. and S all along on the left. Pretty reasonable. Okay. Okay. Do I have an example of this taken already? Oops. Nope. It's okay. Let me take a photo of example 86. Hey, got so chatty. Okay, there we go. Whoa. Wish I could remember if I'm doing 87 too. Okay, let's see here. Oh. Okay. Well, we'll see. It might have covered, but whatever. So example 86, I'll just sneak it from here. Copy. So a retailer of speakers purchases a stock for the manufacturer, or from, sorry, the manufacturer for, there we go, $64.29. In order to determine his selling price, he adds 15% of the cost for overhead and 20% of the cost for profit. Okay. That's one thing, one way we can do it. What is the selling price of the speakers? Okay. So first we're going to outline all the information that we're given. Okay, so we're told that the cost to the retailer, right, so the cost per unit is $64.29. So we're told that the cost is $64.29. So then the overhead, he's saying he needs it to be 15% of the cost. Right? So the overhead, we denote E, right? The expenses, is going to be 15% of the cost. So 15% of the cost we would calculate as 0.15 times C. Here we know the cost, but there's going to be scenarios where we don't know the cost quite yet. So it's good to get in the habit of writing down the general formula, right? So we can work with it. And 20% of the cost for profit. Right? So he's just saying whatever the cost is, I need 15% to cover the overhead and 20% to cover the profit. Okay? So P must be 0.2 times C. So there's a couple of different ways that we can solve it, but we want to find S, right? So in order to determine his selling price, so that's the goal, finding the selling price. All right, so we have all these different components, right? And we said, just now, we said that the selling price is the cost plus the overhead plus the profit, right? So we can use that. So we said that we're trying to find the selling price, and we just said that it's the cost plus the overhead plus the profit. I think intuitively, right, because we know what the cost is, we immediately want to figure out what the overhead is and what the profit is. And that's good. But what I'm going to do is I'm going to write these all out in terms of C and factor it out just to add another element of math. Okay. So then C, even though we know it, I'm just going to write it as C. Okay. C plus 0.15C plus 0.20C, because we said the overhead, right, is 15% of C and the profit is 20% of C. So now we have all these C's. We can collect like terms, right, or just add up the coefficients if we want to, right? But I'm going to factor out the common C. C times 1 plus 0.15 plus 0.20. I get 1.35 times C. I don't need brackets around it. Just a force of habit. Okay. Where C, we know, is 64.29. So sometimes it's actually nicer to just use the variable, even though we know what it is, because then we can collect like terms and collect everything before we plug it in and solve it. Either way you do it, right, you should get to the same answer. So 1.35 times 64.29, you should arrive at a selling price of, 1.35 times 64.29, 86.7915. Right. So the selling price is 86.79, right, to 2 decimal places. So whether you calculated the expenses and then the profit and then sub them all in to find the selling price, you should arrive at the same value. Right. Doesn't matter. As long as you show your work, right? I just wanted to highlight that sometimes it's going to be easier to just keep the variable until the end. It's easier to work with, even though it doesn't feel like it right now. But either way, it's going to be fine. Okay. So, any questions about that one? Just working with variables, all that fun stuff. How about if we do example 88? Did I snap a picture? No, I didn't. Take another photo. See if I can handle it. It's all mayhem up here. 88. Oh. Okay. So then, make it nice and big. I wonder how I can make it default to make it big. Okay. Oh, too small. Okay. So after a markup of 32% of cost for overhead expenses and a markup of 37% of the selling price for profit, a car dealer sells used cars for $14,995. At what cost did the dealer purchase these cars? Okay. the wording of this is a little bit, because we just established that the markup is the overhead expenses plus the profit, right? But if we're just talking, right, we would say a markup of, we would say it just like this question is, right? After a markup of 32% of the cost for the overhead expenses, right? So we have to be kind of flexible in how we read these things. I know that's not helpful when you're just starting, right? But that's how we would talk about it, right? A markup of 32% for the overhead expenses and 37% of the selling price for the profit, right? But both of those make up the total markup, right? So what information are we given here? So we're told that the overhead expenses, E, right, is 32% of the cost, right? So we're going to write that as 0.32 C. We don't know what the cost is yet, right, but that's okay. And a markup of 37% of the selling price for the profit. So the profit is 0.37 times S. Right? 37% of the selling price for profit. Okay. And we're told that the selling price, right, he sells these cars, selling price is $14,995. And we're told to find the cost. So at what cost did the dealer purchase these cars? So find C. Okay. Okay. All right, so let's just write out our general formula, the one that we kind of developed, right? We said the selling price is the cost plus the markup, right? Which was the expenses plus the profit. And let's just plug in the information that we know. We're told that S is 14,995, or I could just leave it as S, right? Because I also see here that the profit has an S in it. Okay. So it might be nice to just leave it as S, but I'll stick with my guns here. Like I said, as long as you're showing your work, it doesn't matter how you do it, whatever feels good. We don't know the cost, right? In fact, we're trying to find C, right? So the C just stays C. E gets replaced with 0.32 times C. Right? We just know that it's 0.32 of the cost, which we're trying to find. So 0.32 C plus the profit, which has to be 0.37 times S. Because I don't want to deal with two variables, right? I want to boil it down to just C because that's what I want to solve for. So I'm going to substitute S equals 14,995 in for S in that profit. So that'll be my first step. I'll have 14,995 is C plus 0.32 C plus 0.37 times 14,995. Okay. So 0.37 times 14,995, because I just did it. I'll write out the rest, but it's going to be 5,548 and 15 pennies even, which is nice. 14,995. Now I'm going to fill in the rest. I start with the work that I need to do because I just can't wait. And then, but I still write out the rest. Right. I'm toying with the idea of collecting my two C's, right? Pulling out the common C and saying C times 1 plus 0.32 or 1.32. I'm going to do it. It's a bold move. Right? I can just, now that we've seen these things a few times, right, I know that C plus 0.32 C is just 1.32 C. Right. Cool. Hey, this looks more reasonable, right? So now we can start by subtracting the 5,000 from each side, right? So we get 14,995 minus 5,548.15 is 1.32 C. So using that same trick, because I have the 5,000 whatever in my calculator, so make a negative and then plus 14,995, it's going to get you the same thing. So I have 9,446.85 is 1.32 C. Solving for C, right, I have to divide both sides by 1.32. So I get 9,446.85, 85 divided by 1.32. So C must be $7,156.70. I'll write out all my decimals just in case someone's checking. So the cost must be $7,156.70. Any questions about that one? So that one's a little bit more involved, right? We started out where we have, what was it? The expenses and the profit in terms of two different variables, right? So that can happen, but just get in the habit of writing out everything you have, using the formulas that you have, right? Plug them in, see where it gets you. Right? Because eventually it will boil down to something like this. Okay. How about another example? Example 90. Oh, maybe I snapped a pic already. No, I got 89, but not 90. That's okay. I'm getting pretty good at taking these pictures, so. Whoop, whoop, whoop. I like this example because it's fun to say. Oops. What the? I think I have an overlap, but oh well. Okay, good enough. All right. Cutie Pie Cosmetic Supply. Fun to say, clever name. We like it. All right. So Cutie Pie Cosmetic Supply obtains boxes of hair dye for $230 per box, less 30% and 10%. So the price is set to cover Cutie Pie's overhead of 20% of the selling price, and to provide an operating profit of 18% of the selling price. What should be the retail price per box? Or rather, we might want to say, what should the retail price per box be? Doesn't matter. All right, we've got a lot of stuff in here. Still no questions back there? Or Cutie Pie Cosmetic Supply? I knew it. I knew it. Okay. So what are we given here? We've got kind of a mix of what we've been dealing with, right? Before we had a net price and a list price and discounts. So that's coming into play, right? But then we also have overhead expenses and profit expenses and markups and blah, 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 right? So we've got a lot of stuff going on here. Okay. So here, I'll just kind of try to, I guess I'll just list them. So the list price, we're told, is $230, right? Because they get it for $230 less those trade discounts, right? To get to the net price. So the list price is $230 per box. And we're told, oops, what the? The first discount is 30%. I'm going to start just writing it as decimals, right? That's what we should be working with. So, okay. And the second discount, oops, D2, is 10%. So that's kind of one set of information. And then if I split it up, so then we're told that the price is set to cover Cutie Pie's overhead. So overhead expenses of 20% of the selling price. So 0.2 S. Right? And to provide an operating profit, so a profit of 18% of the selling price. So 0.18 times S again. And then finally, we're asked, what should the retail price per box be? Right. So the retail price, right, that's going to be the selling price. So we have to find S. So working backwards, right, we want to find S. So let's start there. We want to find S, and then we know we're going to have to do a little bit of maze work, right? But we know that S is the cost plus the overhead plus the profit. Right? I didn't use M because we know overhead and profit, right? So that's good. So we can just plug those in. Which means we have to know the cost, right? But the cost, remember, that's the cost to acquire this thing, which is the same as the net price. So this is the cost to acquire the hair dye which is the same as the net price to Cutie Pie. So that way we can establish that C is the same as N. And that's going to bridge the gap between these two things. And we know that N, right? N we said was the list price times 1 minus D1 times 1 minus D2. And we know the list price was $2.30. Right? And we know the two trade discounts of 30 and 10%. Right? So we can use those to find the net price. That's the price that Cutie Pie pays for the box of hair dye, right? So that's the cost to them. It just gets confusing because we have these two different notations, right? But as long as we recognize that they're the same, right? And then we can use that cost to figure out the selling price, right? S, which is our goal. Okay. So we first solve for N. So N is the list price, which we said was, I'll write it out again, and L times 1 minus D1 times 1 minus D2. The list price was $2.30 times 1 minus 0.3 times 1 minus 0.1. $2.30 times 0.7 times 0.9. $2.30 times 0.7 times 0.9. I get $144.90. So this is the cost per box that Cutie Pie pays. So then we can say something like the cost is the net price, which is $144.90. And we want to find the selling price, right? That's the whole goal. And we already established that the selling price, right, from up here is the cost plus the overhead plus the profit. We don't know the selling price. We're trying to find the selling price, right? And we were just told the cost, but I'll just write it out as it is for now. So C plus, and then the expenses were 0.2s and the profit was 0.18s plus 0.18s. Okay. So leaving our s's alone now, I'm going to plug in my cost, which is $144.90. It doesn't go anywhere else. Right? I can simplify my 0.2s and my 0.18s, right, and just have plus 0.38s. Right? That's allowed. Just add up those coefficients. Yeah. So now collecting like terms, right, trying to solve for S, that's the whole goal here, right? So I'm going to subtract 0.38s from both sides. So I get S minus 0.38s is 144.90. I can, well, technically I'm pulling out the common S's, right, and doing S times 1 minus 0.38, or I can just do 1 minus 0.38 times S. It's the same thing, right? But 1 minus 0.38 is 0.62S is 144.90. So we're so close. The selling price must be 144.90 divided by 0.62. 144.90 divided by 0.62. I get a selling price of $233 and 7096774, just so you can check. So the selling price must be $233.71. Which is not the same as the list price, right? But that's because Cutie Pies decided that they need some amount for the expenses and some amount for the profit. Right? Whew, that's a doozy, right? But if you outline everything that you have, right, then you'll be able to kind of morph the formulas and kind of keep working them over until you get to where you need to be, right? And that's just going to be a practice thing. Okay. So we can talk about the rate of the markup. I know I'm not stopping. Don't worry. There's more. So the rate of the markup or shorthand ROMU, the rate of the markup. Okay. So we can calculate the rate of the markup, calculate the rate of the markup by dividing the markup per unit, right, by the per unit cost. Right? So the rate of the markup by dividing the markup by the per unit cost. Which means that the ROMU are, that looks like a B, a BOMU. The rate of the markup, ROMU, we're going to say is the same as M, right? The amount of the markup divided by the cost per unit. Whenever we're talking rates, right, we have to do give percentages. So technically it's times 100%, but I think if you get a rate of the markup as 0.38 or whatever, you would probably just write it as 38% anyways, right? So you don't really have to worry about the 100%. Just remember that we always report rates as percentages. Okay. We can also talk about the gross profit margin. Okay. So, or we can calculate the gross profit margin. GPM. The gross profit margin is again going to be your markup, but divided by the selling price. Right. Exactly. Again, times 100%. Okay. So those are just fun facts. Those are on your formula sheet as well. Like I said, I should have brought them, but I didn't. Some other things. So we could also show that the rate of the markup is the same as the gross profit margin over 1 minus the gross profit margin. That could be a fun exercise, right? If I ask you, show that this is true. How would you do it? Show that this is true. We're told that the rate of the markup is M over C, ignoring the percentages, the 100%. So we know that the rate of the markup is the markup over C. I might have bit off more than I can chew, but it's okay. C, right? M divided by C, which is actually the selling price minus the markup, right? What am I trying to show here? Oh. Okay. Which is going to be the same as the markup over the selling price minus what am I doing here? Oh, time to abort mission here. That's what I get for not reviewing before I come in. TBD. Yeah, it involves, solving for C is the selling price minus the markup. And then I just can't link it back to the, anyways, not on the spot anyways. I don't have it in here. I'll look it up, show you next day. But we could also show in the same floppy manner that the gross profit margin is the rate of the markup over 1 plus the rate of the markup. These are all on your formula sheet. Right. Now I feel silly because I glanced at this and I thought, oh, that'll be easy to just develop. It is, but I'm forgetting a key step. Okay. How about example 92? Did I take a picture of it? Probably not. Oops. Example 92. No, retake. Got too much going on up here. All right. Good enough. Hello. Good enough. All right. A merchant has a selling price of $13,500 for a small boat. The cost to the merchant is $9,950. Calculate the ROMU and the GPM. So we're told that the selling price is $13,500, and the cost to the merchant is $9,950. And we're asked to find the rate of the markup and the gross profit margin. So remember, the ROMU was the markup over, was it the selling price or the cost? And the gross profit margin is the markup over the selling price. For both of these, right, we need to find the markup. So we need to find M. So we have S and C and M. I know a formula that has only those three. Right? So the selling price is the cost plus the markup. We've been using the expanded version, but we don't need to. So the selling price is $13,500, which is $9,950 plus M. Solving for M, right, we get $3,550. Therefore, if I'm finding the ROMU is M over C, the markup is 3,550 over 9,950. $3,550 divided by 9,950. 0.35678,392. The ROMU is approximately 35.68%. Could have gone to 2 decimal places since I didn't specify. Or 1 decimal place if you wanted to. And the gross profit margin, we said was M over S. So same idea. Once we have the markup, things are easy, right? 3,550 divided by S, which was 13,500. 3,550 divided by 13,500. 0.262962963. The GPM, the gross profit margin, is approximately 26.4%. Just being consistent with my number of decimal places there. Cool. Any questions? Oof, a lot of definitions, a lot of ins and outs. See you guys on Wednesday. On
Monday?
oh, whoops. When
Next one,
when is test one? Hang on.